resonance in series RLC circuit, right? That first one you can take omega equal to 1 by root of LC. Already you know that. That first lesson we derived this. Omega is the angular frequency that is equal to 1 by root of LC, where L is the inductance, C is the capacitance. Or you know that this equation. F is equal to 1 by 2 by root of LC. That is the required frequency. Frequency you can calculate it in the formula. So F is the frequency. F are equal to 1 by 2 by root of LC at series resonance. அப்ப ரெசனன்ஸ்ல இருந்தா என்ன கண்டிஷன் அப்படின்னா என்ன பார்க்க போறோம் அப்படின்னா ஒமேகா ஆர் ஈக்குவல் டு ரூட் ஆஃப் எல்சி ஆர் வி கேன் ரைட் ஒமேகா ஸ்கொயர் மீன்ஸ் தட் ஸ்கொயர் ரூட் கேன்சல் ஆயிடும் 1 by LC. So XL equal to XC means that is in the resonance. So omega L is the resistance of inductance. 1 by omega C is the resistance for capacitors. Now the two values are equal. XL equal to XC. So what will happen when that XL equal to XC in that equation? Z equal to Vm by root of R square. According to Ohm's law, resistance R equal to V by R. That is Vm by. So here it's not exact. So I. Okay, I equal to V by R according to Ohm's law. So Vm by there is R square plus XL minus XC the whole square. Okay, so XL equal to XC means this term becomes 0. So this will become 0 means so what will happen? R square is there. So வெளியே வந்தது அப்படின்னா நமக்கு என்ன ஆயிடும்? R ஆயிடும். So when XL equal to XC. So finally you will get that see that XL equal to XC. So it will cancel each other. Vm by R square. Square root போயிடுச்சு அப்படின்னா we can write R. So I is equal to V by R according to Ohm's law. I equal to V by R. So this is the resonance in the RLC circuit. When XL is equal to XC, this term becomes 0. So Vm by R square root of R square. So square root of R square cancel. So Im equal to Vm by R square. That means the flow of current is maximum. When the XL equal to XC, that flow of the resistance becomes minimum. That flow of current is maximum. Resistance decreases, flow of current increases. Here current is reciprocal to the resistance. Current is reciprocal to the resistance. In that, when the current increases maximum, when resistance becomes minimum, it is used in that RLC application of the series of RLC resonance circuit. So application is that it is used in that TV and radio tuning circuits. So it is used to tune the different frequencies. So the tuning is commonly achieved by varying the capacitance. நீங்க ரேடியோ டேப் ரெக்கார்ட்ல பாத்தீங்கன்னா சைட்ல வந்து ஒரு ரோல் மாதிரி இருக்கு, டியூன் பண்றது ரொட்டேட் பண்ணும். அப்படி ரொட்டேட் பண்றோம் அப்படின்னா we are changing the capacitance value. When you are varying the capacitance value at a particular value, that capacitance value is equal to inductance value. This term becomes 0. That current flow is maximum, so you can hear the sound. So 93.5 FM வைக்கிறீங்க, என்ன வைக்கிறீங்க அப்படின்னாலும் நீங்க டியூன் பண்ணுவீங்க. டியூன் பண்ணும்போது you are varying the capacitance value. So all the input circuit has the capacitors and inductors are in inside that circuit. So when the two resistance are equal, that the resistance become minimum, flow of current is maximum. So current flow in a maximum. So it is used in the tuning circuits for the television and the radio. Okay, or the other communication system also, right? So this is the use of or the application of RLC resonance circuit. So next we are going to see the quality factor or Q factor. So the quality factor or Q factor is used in the RLC circuit. So at which frequency it is occurs in a resonance, that is maximum current. So that's called Q factor or quality factor, or it is defined as the ratio of voltage across LRC. LRC means inductance or capacitance to the applied voltage. So the ratio between the voltage across LRC divided by applied voltage. So this will give the Q factor. So Q factor equal to voltage across LRC. நம்ம இண்டக்டன்ஸ் கெப்பாசிட்டன்ஸ் எவ்வளவு வோல்டேஜ் கொடுக்குறோமோ டிவைடட் பை அப்ளைடு வோல்டேஜ். அது நம்ம பவர் சப்ளை இருந்து கொடுத்துருப்போம் ஒரு வோல்டேஜ். ஸோ தட் இஸ் அப்ளைடு வோல்டேஜ். The ratio between the two voltage gives the Q factor. So then Q factor for inductance XL, that is V equal to IR. So instead of suppose we are taking that LRC, now we can take the inductance. That's why here we are writing XL. XL is the inductance reactance, that is XL. IR, V equal to IR according to Ohm's law. So IM XL divided by V equal to IR, so IM R. So IM cancel each other, so XL by R. So that is the Q factor, that ratio. So instead of XL, we can write omega L. So omega, you know that value 1 by root of LC. So substituting that value here, omega Q factor L by root R into root of LC. So Q factor equal to, நம்ம என்ன பண்றோம் அப்படின்னா L ரூட்ல கொண்டு போனீங்கன்னா இந்த L கீழே இருக்கிற Lக்கு கேன்சல் ஆயிடும். L ஸ்கொயர் பை L ன்னு வரும். L ஸ்கொயர் கேன்சல் ஆயிடுச்சு அப்படின்னா 1 by R root of L by C. So this is the Q factor. The physical meaning is the Q factor indicates the number of times the voltage across LRC is greater than the applied voltage at resonance. So applied voltage இந்த voltage வந்து அதிகமா இருக்கும். So voltage across LRC is greater than the applied voltage resonance. Right? So it's called quality factor or Q factor. Okay. Then next we are going to see the power in a AC circuit. சரி, ஒரு ஏசி சர்க்யூட் இருக்கு, அதுல எவ்வளவு பவர் இருக்கு, அது எப்படி நம்ம கால்குலேட் பண்றது? ஸோ வாட் இஸ் த பவர் ஆஃப் த ஏசி சர்க்யூட் அப்படின்னு பார்க்கலாம். ஸோ பவர் ஆஃப் a circuit is defined as the rate of consumption of electric current in that circuit. Rate of consumption. So how much the amount of energy we consumed from the external circuit. That is called power in a AC circuit. That is consumption of the electrical energy. That is called power. Right? So we know that V equal to Vm sin omega t, that is for potential. For current, I equal to Im sin omega t plus phi. So plus phi means we are taking that current leads the voltage. That means we are connected the capacitor. It's understood. Okay. So power equal to, you know the formula, V into I. Power equal to V into I. So V equal to Vm Im sin omega t into sin omega plus phi. So here it is a formula for sin A plus B. So expanding that, you can get this sin omega t cos phi minus cos omega t sin phi. So on simplifying this, you are multiplying that sin omega t with that term. So you will get this. Then V average equal to Vm Im and cos phi into 1 by 2, because sin square omega t becomes 1 by 2 and remaining values are become 0, right? So that's why it gets a cos phi into 1 by 2. So 1 by 2 we can write root 2 into root 2. So Vm by root 2, Im by root 2 into cos phi. Here Vm by root 2 and Im by root 2 is called Vrms and Irms. So here our average equal to Vrms into Irms into cos phi. Here Vrms and Irms is called apparent power. So that's called a apparent power, and cos phi is called power factor because that is depending on that the pi value. So it's called power factor, that's cos phi. So in that, when the purely resistive circuit, for special case, you are taking that purely resistive means that P average, that is power average equal to Vrms into Irms. Cos phi becomes 1 for resistive circuit. For purely inductive or capacitive, முதல்ல ரெசிஸ்டிவ் அப்படின்னா Vrms into Irms வந்துருச்சு. இல்ல இண்டக்டிவ் ஆர் கெபாசிட்டிவா இருக்கும் அப்படின்னா the P average becomes 0 because it has cos phi as the plus or minus pi by 2. That means 0. For series RLC circuit, the phase angle pi equal to tan inverse of XL minus XC by R. ஏற்கனவே நம்ம பார்த்தோம். R that is equal to P average equal to Vrms Irms into cos phi. For series RLC circuit at resonance, the phase angle is 0 and cos phi equal to 1 means you can get the maximum power average. P average equal to Vrms into Irms. So cos pi equal to 1. அப்ப cos pi equal to 1 ஆயிடுச்சுன்னா RLC circuitல at resonance condition. So P average becomes Vrms Irms cos pi அப்படின்னு நமக்கு கிடைக்கும். Okay. So